Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. We are into unit number 1 where we are studying about finite automata. So we have discussed a lot of things about what does automata means, then what are the different types of automata. We have also discussed about deterministic finite automata, and we have also discussed about non-deterministic finite automata. So we have seen a lot of examples regarding how to construct NFA and DFA. Okay, if you have not undergone these kind of lectures, then you can get back to my previous lectures. Okay, so all the lectures has been mentioned serially, and if you want to see what and all topics are there in unit number 1, you can see the first video where I have introduced all the lecture series topics. Okay, now in this particular topic lecture, we will be learning about the conversion process of how to convert a non-deterministic finite automata to a deterministic finite automata. So the most common method that is being used is subset construction method. So it's a very easy option of how to convert a particular NFA to a DFA. Okay. So sometimes in your question paper, it might be like you might be given a particular language, and from that language you have to construct an NFA first, and then you have to convert it into DFA. Okay. So this is how the question may arise. So I have taken an example over here, and there is no such algorithm. So if someone asks about what is subset construction method, then you can explain this particular conversion process, and you can take an example and you can explain that. Okay. So basically, you know that NFA is equivalent to DFA, right? But since every DFA is an NFA, therefore we have to perform only conversion from NFA to DFA only, correct? So let us take an example where the language is given to you as, for the language L is equals to language starts with A and over input alphabet given as A comma B. Okay, so that means I have drawn the diagram right now because the construction of NFA is already done, and this example is also done in your exam, in your examples. Okay, so you can, if you haven't understand how to construct an NFA, you can get back to my lecture series. Okay, so here I have to draw a NFA which starts with A, correct? So the restriction comes over in this particular point that starts with A. So initially what I will do, I will take an initial state and I will take another state, let it be B, and I have started this transition with A. So that means there is no condition of coming B over here. So I have taken only A and I have taken this as a final state. Clear? And in this particular loop after A, there is no at all restriction. So I have taken a self loop and I have drawn a comma B. So that means after A, it can be a possible combination of any between A and B, right? So that's why this is the final diagram for NFA. Now I have to construct this NFA, convert this NFA into a DFA. So first step is, if the language is given to you, then first step is this one, to construct the NFA. Second step is to construct a transition table for the NFA. You know how to construct a transition table for a particular NFA or a DFA, right? So I have to take a table where the column wise it will be state and the row wise it will be the input alphabet. So according to the input alphabet A and according to the input alphabet B, we have to cross verify that these initials how the transition is flowing. Okay, so initial state is A, so I have taken this as A. Okay, so let us check A, the state A, on seeing the input alphabet A, where it is going to B. So I have to write down as B. Okay, here then A, state A on seeing input alphabet B, it's going somewhere? No, it's not going anywhere. So you can use epsilon in this form, or epsilon also you can use, or you can use a phi. Okay, generally we use this one, this symbol. Okay, that's not a big deal. Okay, next, now state A is done. Now I will look into state number B, and state number B is, we know that it's a final state. So final state is being represented by star, right? Now state B on seeing A, where it is going to the itself. So again same. Then again state B on seeing input alphabet B, it is going to its own self. So again state B. So this is completed. So transition table for NFA is done. Now step number 3 is that we have to find out the transition table for DFA. Okay, how to do this? See, the initial step, the initial row will be as it is. Okay, so I will write as it is: A on sync A, B on sync B, 5. Okay, in some books and in some reference, you can see that it is mentioned like this. Okay, you can also write down like this. There is no issue about that. Okay, now it is done. Now what is the new state? Now we have to check what is the new state according to construction of the transition table for DFA. Once we write the same row as it is, after writing, we have to check what is the new state after A. After A, new state is B. So let me write down B. Okay, as we know that B is a final state, so I can mark it as star here. Now I have to check that now I'll be starting off with the state B, right? So I have to check that B on sync A. B on sync A, where it is going. See, since it is a single state, so nothing to do. B on sync A, where it is going on B. Clear? Then B on sync B, where it is going in B. So there is no other possible states. Now I have to do one more thing, that in this scenario, I am done with all new states. See, any other new states here? No. This epsilon is there as a new state. You can check it out. So this is actually known as a date configuration. This is known as date configuration. Now, if suppose after conversion from an NFA to DFA, you got a date configuration, then you have to take one more state, that is known as date state. Clear? And what will this date state will be working? This date state will be working like this: D on sync A, where it is going itself. Date state is like you have to draw a self loop, okay? And these D on sync B, where it is going into the same state, correct? So this will act as a date state, okay? And as we have to remove this date configuration, so in this place of phi, what I have to write? I have to write down as D. So this is your final diagram. So this is a simple example, but yet complicated, because maximum of the time when you convert this table into a DFA, you will get the same answer. But in order to remove this phi, because what DFA says that from every state, for every input alphabet, there should be a transition. So if phi occurs, then it will not be considered as a DFA. For removing this phi epsilon, we have to take null. We have to take a date state, state known as date state. Date state means wherever transition is coming to this particular state, there is no transition going out from this state to a final state. So that kind of state is said to be a date state. Now this is done. This table is completely done. See, for every state there is a 1-1 transition for input alphabets. So finally we can draw the diagram. The diagram will be like this. So I will be so let me draw all these states. So A will be coming over here, B will be coming over here, and D will be coming over here. Okay, so as B is the final state, so I have drawn B as a final state. As A is the initial state, so these things you please keep in mind, that you please never ignore this while drawing the final diagram. Okay, so A on sync A, where it is going to B. A on sync A, where it is going to B. A on sync B, where it is going to D. Okay, clear? Then B on sync A and B, both are going to the same state, so I can put a self loop, A and B. Then D on sync A and B, where it is going to itself. Correct? So now you can check that for every state there is 1-1 transition. Correct? So now this is your final diagram for this particular one. Clear? So any doubt? If you're having any doubt, please comment down below. Now I will be moving to a little bit of another one example. Okay. Okay, so this is one more example, example number 2. Example number 3 I have brought for you. Okay, I will explain. I won't take much time. So example number 2, you please look into this. The NFA is given to you. How did you came to know that this is an NFA? See, for state A, we are having multiple number of outputs for this input A. A is going to B, and A is also having a multiple self loop over here. And similarly, C is not having any transition. So you can directly assume that this is, you can find out that this is an NFA. Now I have to convert this NFA to a DFA. So step number 1 is the transition table for NFA I have to write down. So this is your step number 1. Clear? Now step number 1, in step number 1, initial state is what? A. A on seeing A, where it is going? It is going to 2 states. See, one it is going to itself and one it is going to B. So I can write down like this: A, B. Clear? Then A on seeing B, where it is going? A on seeing B, it is going to itself. If you give a square bracket, then it gets beautiful. Okay, it gets like a systematic way of representing it. Okay, so now I am done with the initial state. Then I will be going to the next state. Okay, only with DFA you have to take the new states. Okay, so now we will simply write down the transition table for this diagram. Okay, now B on seeing A, it is going to C. B on seeing small letter b, it is going to C. So for both the symbol, it is going to C only. Clear? And finally, we are left out with C. C being the final state, so I am marking as a star. Okay, so C has no input transitions, right? So that means it will be phi, null. So my transition table for NFA is done. Now moving back to transition table for DFA, this is your step number 2. Okay, transition table for DFA, what it will be? See, I have already told you, whatever NFA transition table we are having, the first row will be as it is. So A I have drawn, A, B and A. Clear? Now after A, what is your new state? Only AB, right? A already I have done. So AB is the new state, so bring it over here. Okay, now how to find out AB? How to find out the transition for AB in case of input alphabet A in input alphabet B. Now get back to the transition table for NFA and hold it together, this A and B. Now if we check for A and B together, for input alphabet A, where it is going? A, B and C. Clear? Again I am repeating. See, I am now considering for AB. I am finding out for AB, right? So in this transition table for NFA, you take together these two things. Okay, A and B states together. Now if I check together for input alphabet A, where it is going? It is going once in AB and the other in C. So both will combine as ABC. So I will write over here as ABC. Clear? Now moving back to same way for input alphabet B, where it is going? A and C. So together it will be forming as AC. Clear? Now this new state is done. After AB is done, now new state is what? ABC and AC. Now first bring over ABC or AC. It depends on you. It doesn't matter at which state you are bringing. Okay, now I will check for ABC. Okay, since C was the final state, so whatever combination of elements, whatever combination of states with C, it will be considered as a final state. So this will be considered as a final state. Now ABC I have to check. So ABC together I have to take. For input alphabet A, where it is going? A, B, C and phi. So together it will be A, B, C. Clear? Now if I check in with input alphabet B, where it is going? It is going to A, C and phi. So A, C, phi means what? AC only. Clear? Now what state is left out? New state only left out is AC. So I will bring AC over here. And since C is a final state, so combination of C with any state will be also a final state. So AC will also become as a final state. Clear? Now AC I have to check. Now these two states I have to check, right? A and C together on seeing input alphabet A, where it is going? AB and phi. That means AB only. Clear? Phi means null. Then AC together on seeing input alphabet B, where it is going? It is going to A and phi. So what will be the answer? A only. Now you check that whether any new state is left out. No, all states have been traversed. So this is your final transition table for DFA. Now I have to convert this particular diagram into transition table into the diagram. So how to draw? Whatever states are here, I have initial state, also I have final states as well. Whatever states you have find out, you just draw as it is. Okay. So I will first write down for A. Then I will take for AB. Then I will take for A, B, C, and as it is a final state, so I am drawing as a final state, and one more state will be there, that is your AC. AC is also a final state, so I'm marking as final. So I have drawn all the states. Now initial state is A. Okay. Now A on seeing A on seeing input alphabet A, where it is going? AB. A on seeing input alphabet B, where it is going? To itself, correct? So I can draw a self loop. Sorry, this is B. Okay. Now next A is done. Now AB. AB on seeing input alphabet, where it is going? ABC. Correct? AB on seeing B, where it is going? AC. See how beautiful it is. Now ABC on seeing A, where it is going? ABC. So this will be a self loop. ABC on seeing B, where it is going? AC. Clear? And finally AC on seeing A, where it is going? AB. AC on seeing A. AC on seeing B, where it is going? To A. Okay, so I have to draw a bigger one transition for this, and this diagram, this transition is for B. Clear? So this is your final diagram for, this was the NFA and this was the DFA. You can check for every state there is one transition for the input symbol. So this is all about your example number 2, where you have also studied about how to convert a typical one. And this is your final example that I brought for you. Okay, you can pause the video and you can try on your own. So whatever I have done is that same. This is the transition table for this. Okay, as I have already explained you here over here. Okay, after this, how to do it again I will explain to you. Okay, now A, B, C, D. Okay, the first row will be as it is. See, okay, what is the new state I have got after A? AB. AB I have brought. When I checked AB together for input alphabet A, where it is going? ABC. See, ABC came. For B, where it is going? AC. AC came. Correct? Then what is the new state over here? ABC and AC. So first I have done AC. You can do ABC as well. So I have taken AC. See, A and C together, if I take for AB, where it is going? A, B and D. So ABD came. So the new state came. Correct? Then AC on seeing for input alphabet B, A and C, A and D. So AD came. Correct? So a new state came as ABD and AD. But beforehand ABC was left. So ABC I took. So when I checked A, B, C together, then I have find out that A, B, C, D came. Correct? So A, B, C, D I have given. Then when I took A, B, C for input alphabet B, where it is going? A, C, D. A, C, D. Correct? Now new states. What are new states? ABD, AD, ABCD, ACD. Correct? So I have done first AD. Okay. Since D was the final state, so combination of D will be your final state. So AD will be a final state now. AD together when on scene for input alphabet A, it was AB only. So AB. Correct? AD on seeing B, where it is coming? A and phi, that is A. Clear? So AB and phi already done. So AB and A already done. Keep as it is. AD is done. Now what will be the next state? ABD is the next state. So ABD I have checked. A, B and D. What is the possible combination? A, B, C and phi. So answer will be ABC. See, ABC. A, B and D. A, C and phi. So AC will be the one. Clear? These two are already done. So leave as it is. Now a new state came is ACD is left out and ABCD is left out. So ACD I have brought A, C and D. That means AB, D and phi. So answer will be ABD. ABD. ABD is already done. So then this is not a new state. And ACD, A, C and D on seeing B, A, D and phi. So AD will be the new state. Correct? So but this is not a new state, already been done. Only left out is ABCD. Now ABCD, when you check for A input alphabet together, then it will be A, B, C and D. So ABCD. Clear? Then ABCD for input alphabet B, it will be A, C, D, phi. So ACD. ACD is already done. ABCD is done now. So this is your final diagram, final transition table for your DFA. Now if you check, now if you can draw this diagram, it's very easy. First draw all the states, okay, in a paper. Then try to gather for A where it is going, for A to B where it is going. like this you have to draw the entire diagram. Just now I have drawn over here. Okay, so this is all about the conversion of NFA to DFA, and I think these 3 examples are enough to understand the concept behind this. I would suggest practice makes a man perfect. You just keep on doing few more examples, then it will be very much clear to you all. Okay, thank you for watching the video. In the next lecture we will come up with a new topic as per scheduled in our lecture number 1, where I have mentioned you what are the topics we are going to cover. Okay, thank you for watching this video. Stay safe, and if you're having any problem, please comment down below. Suggestions, comment down below, and do subscribe my channel. Thank you.